Humanity stands at a crossroads, our gaze drawn towards the stars. Two celestial bodies beckon, promising escape from a world grappling with its own mortality. Mars, the red planet, stirs our pioneering spirit, a familiar dream of conquering a new frontier. Yet Titan, Saturn's enigmatic moon, whispers of untold possibilities shrouded in an atmosphere thicker than our own. The question that grips our collective imagination is not if we will leave Earth, but where we will choose to build our second home. Will it be the rusty plains of Mars, a world we've imagined terraforming for generations? Or will it be the frigid, methane-rich surface of Titan, a world so alien it challenges our very understanding of life itself? The stakes are higher than ever before. Our future as a spacefaring species hinges on making the right choice. The journey will be fraught with challenges, demanding technological innovation and unwavering human resolve. But the rewards, the chance to secure our legacy among the stars, make this the greatest adventure of all. Mars has captured our imagination for centuries. Its proximity, a mere hop compared to Titan's vast distance, makes it a tantalizing target. We have studied its surface, mapped its canyons and volcanoes, and even landed rovers to explore its secrets. Mars whispers promises of a new beginning. Its day-night cycle, similar to our own, offers a comforting familiarity. The presence of water ice, locked beneath its surface and in its polar caps, holds the key to sustaining human life. And its thin atmosphere, while requiring pressurized habitats, offers some protection from harmful radiation. The dream of terraforming Mars, transforming it into a habitable world, fuels our ambition. Imagine vast fields of Martian crops, shimmering lakes reflecting a blue sky, and humans walking freely beneath the warmth of a Martian sun. It's a vision that has inspired countless scientists, engineers, and dreamers alike. But Mars, for all its allure, presents formidable challenges. Its thin atmosphere offers little protection from solar radiation and meteoroids. Temperatures fluctuate wildly, plunging to bone-chilling lows that would test the limits of human endurance. The lack of a global magnetic field, a natural shield against cosmic rays, poses a significant threat to human health. Long-term exposure could lead to increased cancer risks and other health complications. And the very act of terraforming Mars, while theoretically possible, would require technological feats that are centuries, if not millennia, away. The journey to Mars is perilous, a months-long voyage through the unforgiving vacuum of space. And once there, colonists would face the daunting task of building a self-sustaining civilization from scratch. Every resource would be precious, every decision a matter of life and death. Titan, in stark contrast to Mars, is a world of mystery and wonder. Shrouded in a thick, nitrogen-rich atmosphere, it's a moon that resembles a planet in its own right. Methane rain falls from its skies, forming rivers and lakes that carve through its icy surface. Titan's atmosphere, while unbreathable for humans, offers a surprising benefit: protection. It shields the surface from harmful radiation, making it potentially safer than Mars in that regard. And the abundance of hydrocarbons, the building blocks of life, hints at the possibility of indigenous life forms, albeit ones vastly different from our own. Titan's low gravity, even lower than that of our moon, would make landing and launching spacecraft easier than on Mars, and its dense atmosphere would provide a natural braking mechanism, reducing the need for complex and fuel-intensive landing procedures. Beneath Titan's hazy orange sky lies a world ripe for exploration. Its vast reserves of hydrocarbons, in the form of methane and ethane lakes and seas, could provide an abundant source of energy for future colonists. These hydrocarbons could also be used to produce plastics and other materials, reducing the need to transport them from Earth. Titan's subsurface ocean, thought to be composed of water and ammonia, offers another tantalizing possibility: a potential habitat for life. While the surface is too cold for liquid water, the ocean's internal heat, generated by tidal forces from Saturn, could create conditions suitable for life as we know it. Exploring Titan's subsurface ocean would be a monumental challenge, requiring advanced drilling techniques and autonomous underwater vehicles capable of withstanding extreme pressures and temperatures. But the potential rewards, the discovery of extraterrestrial life or even a habitable environment, make it a risk worth considering. The long-term success of any colonization effort hinges on our ability to create self-sustaining environments. Both Mars and Titan present unique challenges and opportunities in this regard. Mars's thin atmosphere and lack of a global magnetic field make it difficult to grow crops outdoors. Colonists would likely rely on hydroponics, growing plants in nutrient-rich water solutions, and vertical farming techniques to maximize yield in limited spaces. Titan's thick atmosphere and abundant hydrocarbons offer a different set of possibilities. Colonists could potentially create biodomes, enclosed environments where they could grow crops and live in a more Earth-like atmosphere. The hydrocarbons could also be used to generate electricity and power greenhouses. The key to sustainability lies in resourcefulness and innovation. Colonists will need to find ways to recycle and reuse everything, from water and air to waste products. They will also need to develop new technologies and strategies for living in extreme environments. Reaching for the stars will require nothing short of a technological revolution. We will need to develop new propulsion systems capable of shortening travel times between Earth and our chosen destination. Nuclear fusion propulsion, a technology still in its infancy, holds the promise of significantly faster travel times, potentially reducing the journey to Mars to a matter of weeks. We will also need to develop advanced life support systems capable of recycling air, water, and waste products with near-perfect efficiency. Closed-loop systems, where waste is treated and reused, will be essential for long-duration space missions and for creating self-sustaining colonies. And we will need to find ways to protect our colonists from the harmful effects of radiation, both during their journey and once they arrive. Shielding materials, radiation-resistant medications, and even artificial magnetic fields are all areas of active research. Some argue that we are in a race against time, that we must colonize space to ensure the survival of our species. Climate change, resource depletion, and the ever-present threat of nuclear war cast a long shadow over our future on Earth. Others believe that we should focus on solving our problems here on Earth before venturing out into the cosmos. They argue that the vast resources required for space colonization could be better spent addressing poverty, hunger, and disease. The truth likely lies somewhere in between. Investing in space exploration can lead to technological advancements that benefit humanity as a whole. And establishing a human presence on another planet could serve as an insurance policy, a safeguard against the possibility of a catastrophic event on Earth. So, which celestial body holds the key to our future? Mars, the familiar red planet, offers proximity and the potential for terraforming, but it presents significant challenges in terms of radiation, resources, and long-term sustainability. Titan, the enigmatic moon, offers abundant resources, radiation protection, and the potential for indigenous life. But it's a far more alien environment, requiring us to adapt to extreme cold and a methane-rich atmosphere. There is no easy answer, no clear winner in this cosmic competition. The choice of where to colonize will depend on a complex interplay of factors, including technological feasibility, economic viability, and ultimately, our own human values and aspirations. The decision of whether to colonize Mars, Titan, or both will have profound implications for the future of our species. It will shape our technology, our culture, and our very understanding of what it means to be human. Imagine a future where humans live on 2 planets or even more. Each colony would develop its own unique culture, shaped by its environment and the challenges of its existence. We might see the emergence of new forms of government, new social structures, and even new branches of science and technology. The colonization of space is not just about escaping Earth's problems. It's about embracing the unknown, pushing the boundaries of human ingenuity, and ensuring that our species has a future among the stars. The choice is ours to make, and the time to choose is now.